So this is actually pretty interesting because there's a lot of misconceptions about this. In relation to a topology, there's really two different categories that you can immediately throw something into when you say something like a hybrid topology. Some people, maybe who are kind of older in the space and used to stuff from back in the day, it would be more focused on networks that are based on a physical setup. So you have specific network related hardware to elicit some type of topology. Let's say if it's decentralized, it would have a physical network that would resemble a decentralized topology, as opposed to a software-based topology like Bitcoin has, or BitTorrent. BitTorrent is probably the closest in terms of there's centralized aspects like trackers, but at the same time, that content and that information is coming from a decentralized network. That doesn't take any type of fancy hardware or networking or anything like that. It's just software. From our perspective, we're taking the same approach. This is kind of this new trend called software-defined networks, where we're moving away from having these really complex devices, network-related devices, to handle a lot of the connections and where things go and whatnot. Now we're kind of passing that. Everything is kind of just like a computer, and you can program that thing however which way, and it will handle things appropriately. In our regard, the topology for the hybrid bit, first of all, there's two different networks. The web part is about you can get onto a site which is centralized, but at the same time, you can benefit from, say, a decentralized DNS. For us, it's called the DIS, or you can do something like a P2P CDN. So you get some assets from the centralized service, but at the same time, you can pull in assets to people who might be geographically closer to you. And you would get, obviously, information a lot quicker because it doesn't have to traverse the same amount of space and time. But for Viot, this is flipped. So Viot is decentralized, first and foremost. With that being said, though, there's centralized bits that enhance it. So you can do stuff like instant transactions, like you would see on PayPal, or wallet security. Now, keep in mind, though, that's opt-in. On both network types, so on the universal web, the centralized bits are opt-in, and on Viot, the centralized bits are opt-in. So an interesting thing in relation to DSP packets is they kind of have this built-in DDoS protection by making the first packet the client sends larger than the packet that the server would respond with. Basically, it raises the cost of DDoS attacks. But another aspect to that, so first of all, DDoS attacks obviously cost companies tons of money. We're talking billions of dollars a year. But with that being said, there's these puzzles that are Viot-related puzzles. They're really just proof of work bits from Viot that are embedded actually in the response packets that servers could give out. And that's dynamic, that's not always on. So with that being said, they can turn a DDoS attack into something that usually costs them money into something that can make them money. Now, of course, they're still going to get hit large in part by the DDoS attack, and they'll probably have some type of downtime. But in the process, at least they're recovering some type of funds. They're doing some type of work in relation, obviously, to Viot. Another aspect in terms of time and money saved is relation to the amount of hardware you need to accomplish the same goals. So the idea with a lot of the stuff we're building is how can you do the same amount of work or more with a whole lot less? And when it gets down to resources, that's expensive. That's utilities, that's bills, that's bandwidth. It's big money, especially if you're running something like Netflix or Amazon. Now, in the process, if you're using more and more hardware because the software that you rely on is not updated, it's not adapted to modern needs and modern features, you're going to obviously pay a lot of out of pocket for that. So with that being said, if you adopt something like UDSP, and let's just say they adopted the protocol itself, they would save a ridiculous amount of money because you're not spending all this time basically going back and forth with acknowledgements and data. You're just doing a zero RTT connection instead of a three-way or four-way handshake, whatever you end up having now, and you're saving a ton of data in the process. Now, if you just look at one request, it's a very small amount of data, but if you look at a lot of requests en masse, it's a lot of data being saved. That's a lot of bandwidth. What does that mean? That means a lot less computational power wasted, which is a lot less electricity bills. There's a lot less bandwidth, which is a great thing in terms of a bandwidth bill, and these big companies pay for bandwidth. It's not like the same plan that you and me would have. Oh, we have X amount of dollars a month for just this one connection. They're going to buy bandwidth because they're using so much of it. It's a totally different plan. Net neutrality in the States, I'm not sure how it is out of the States, but I can tell you in the States it's highly political. Uh, they've kind of gotten, and by they I mean companies that would not benefit from the repealing of net neutrality. So for example, big companies that rent large amount of bandwidth. So Comcast rents bandwidth, uh, Amazon, Netflix, a lot of these big companies, they pay a lot for bandwidth. With that being said, it's in their interest to make it into a political situation where people now get riled up because they think that these big companies are, just trying to, you know, uh, get more money out of you and make up all these ridiculous plans and everything. But in reality, it was repealed because it's a utilitarian problem. We're dealing with an issue that's a very modern one, and we have all these new devices coming online. We have developing countries coming online. There's more devices per person, more devices per household. Your coffee machine tells you the weather. You have self-driving cars. A lot of these new features, even on the web, like WebSockets, real-time, anything at that rate sucks up a lot of bandwidth. It's constant communication. So it's not about how much data you're sending necessarily, it's about how much data you're sending at a single point in time. So that's the main issue that they're addressing there. By having data prioritization and fast and slow lanes, you can appropriately handle this problem through network congestion. Now, the way we approach this is network congestion and the problems we have, a lot of it is from, and at least it arises in part from not just the people coming online, but the core technologies that we rely on, like DNS and HTTP. A lot of these things need to be changed. They need to work together because DNS and HTTP really don't work together like UDSP and the DIS does. The DIS obviously gives you a certificate with the routing information. The routing information is really the only thing you get back from the DNS now. And then obviously you can go to the service and then you ask for the certificate. On ours, all that is wrapped up into a single request and a zero RTT connection for the DIS. So you're saving all this time and bandwidth and resources to do the same exact thing. It brings us back to the idea that, how can we do a whole lot more with a whole lot less? You just have to be smart about these things. You have to really understand the modern needs and modern demands to revolutionize these. Years ago when the World Wide Web was being developed at CERN, they didn't have the ability of, looking back in time and using hindsight where everything's very clear. We had to go through all of this and experience all of this to realize that this is what we want, this is what we need from our networks, these are the features that, we're moving towards. Everything that, in terms of the features for the web now, like you have HTTP, and then for real-time stuff, you use something like WebSockets or WebRTC. For us, all of that is wrapped up into one thing, UDSP, and it can handle various types of requests in a dynamic fashion. So you can have stuff like video streaming, but still have some sort of dynamic reliability algorithm instead of relying on something like HTTP, which has a very static reliability algorithm where it'll send you one and be like, did you get one? Be like, yeah, I got one. And then you have to send them two. And then he has to go, yeah, I got two. For us, it's send it in whichever order you want. If it's a static asset or even a dynamic one, you can send it in any order you want, as long as the UDSP knows the total amount of chunks that make up all that data, basically the amount of packets that make up a full, your full data set. It can reorder that data appropriately, and boom, you're good to go. So it doesn't have to wait for networks or any other side to sit there and go, okay, did you get that? Basically, it doesn't have to go through what I would consider dumb acknowledgments. It's lazy, but at the same time, it's smart about it. Neutrality really gets more complicated from a political perspective than it is from a purely utilitarian one. Like I was saying before, they made this into a political issue so they can get cheap bandwidth by proxy. And the proxy just so happens to be the blind masses that don't realize that this problem is far more complex than they want to make it out to be. The reality is that our networks are not outpacing us. We're outpacing our networks, and our demands are growing exponentially faster, and it's becoming a huge problem to the point where we need to have data prioritization, we need to have fast lanes because of congestion, really just as a form of congestion control. It's the same thing in concept as having the Cloudflare loading page or having Google CAPTCHA. Congestion control happens at many different layers, even in the protocol. For us, it happens obviously in UDSP packets with puzzles. But yeah, by having stuff like that, we can avoid a lot of these issues for years to come. The reality is that at some point we will, outpace our networks, and we will need to swap to something like, for example, quantum networks. And that gets really interesting in terms of cryptography because you have something like, basically, it's a quantum key exchange where you use quantum superposition. Basically, there's these two things that are interlinked between, over space and time, and any sort of observing on that process or interfering in that process, the key exchange automatically breaks, and it's far more efficient. It's faster. There's a lot of benefits just having that type of network, but that's where we're heading. So regardless, we're going to face this issue. It's just how can we, first of all, fix the big problems that we have now to buy a substantial amount of time to develop better networking technology where, right now we got to the point where we can send light over a wire. The problem is, light in a closed tunnel is totally different than sending light, where it's just open. Basically, if you send light over, a wire like a fiber optic cable, it's actually not the same speed as the speed of light. It's actually much slower. So our entire perspective is long term, throw everything out and revolutionize everything possible and make it so that it's for the web of tomorrow, not the web of today. Design it for future needs, not just our modern needs. But with that, in that respect, HTTP doesn't exist on our platform. The DNS doesn't exist, period, on our platform. All these things are rewritten from scratch from a straight up node UDP server. After that, I think the only thing besides obviously a cryptography library, but we're getting into like dependencies. And in that regard, pretty much everything is built on something at that rate. But yeah, like cryptography, we won't be writing our own cryptography library. We only use, battle-tested stuff like libsodium. We won't even use stuff like AES. If there's any type of doubt in relation to it, we're not going to use it. What we use is called XChaCha20. You can look this up on libsodium. We use also the key exchange algorithm that basically just computes a set of shared keys, send and receive keys, using, let's say, where you want to send it. So the services, let's say, their public key and your private key, and then you can generate, two shared keys. And when you send over the 0RTT packet, your UDSP packet, and your identity certificate is in the packet, the server can immediately go, okay, I can compute the two shared keys now using your public key and their own private key, and boom, they can immediately decrypt the packet. So that whole process, all of that stuff, especially in relation to the protocol, is totally from scratch. The cryptography libraries will never do from scratch unless we have that stuff in-house, but chances of us doing that is not likely. After libsodium, hopefully we go to a library that has a standardized version of super singular isogeny Diffie-Hellman key exchange, or just a super singular key exchange where you're relying on basically stronger mathematics to encrypt packets instead of what we have now. It's all just mainly because of you want quantum resistant stuff for the future, but a lot of this isn't really standardized. It still needs to be battle tested, and it's not really needed now. We're still a ways off before we have a quantum computer with Shor's algorithm on it that can rip through a lot of like the elliptical curve cryptography that we have. In terms of the way the packets are encrypted, though, with XChaCha, those are quantum resistant by default. Same thing with hashing and whatnot. There are obviously old hashing libraries or old hashing algorithms. Same thing with straight up encryption. But obviously those aren't used anymore. They're not even a thing, and they've obviously been phased out. In terms of stuff we do use, we have Electron as our shell. So the Electron shell, if you go to electronjs.org, which is what the Atom editor by GitHub uses, a lot of apps like Skype, for example, use it. It's essentially it's just a shell that has a nice little marriage between Node.js and Chrome. It's really a Chrome shell though. So Chrome is the front end and Node.js would be the back end. That's something we obviously use. But other than that, yeah, I mean, you can look at our dependencies in our package.json and those are the dependencies, but the technology that we actually are using, the higher level stuff like the data transport protocol, the certificate format, all that stuff is us. Um, Even some of the dependencies that we have are dependencies that we made, like the utility libraries, Acid.js, Lucy.js, that's all us. If it comes to the documentation generation library, Doc Redux, that's us. The unit testing library, Testatron, that's us. There's a lot of utilities and dependencies that we made ourselves in-house that are also a dependency, obviously, of Sentivate. But a majority of the technology we made is just that. It's our own. We made it. It's in-house. A majority of the value is obviously from that. We want to obviously in the future make our own browser or our own web-based language. You know, JavaScript's great, but it has a lot of issues in relation to basically optimization. So there's a thing called static types, and languages that have it can more easily be optimized from a compiler's perspective, but JavaScript's dynamic. It doesn't have, it's not statically typed like how C++ would be. So there's a lot of caveats to that. And the main caveat is from a performance standpoint. The benefit is that, you know, you're not typing that, and thus you're saving time. But I'd prefer from just a development standpoint to have stuff like that. But yeah, like there's things like that long term that we want to work on. Yeah, when we get this question, it's kind of interesting because we stick out like a sore thumb when you actually look at all the projects in this space, or even you know, a space within the space. In this space, I consider it like anyone who wants to do a replacement for the web today. So in that regard, there's basically everyone else, and then there's us. Everyone else it's a Web 3.0 blockchain-based web, like Waze, for example, is doing their new web, which is still blockchain-based, still has massive decentralized aspects to it. We know that that will never work. That's a pipe dream. It's totally unrealistic and non-viable. If you want to transfer assets to a client, you're thinking, hey, how can I do this in 300 milliseconds or less? You know, there's no time to send a message and then have to pay for that message, have it go through a consensus algorithm, then eventually propagate to nodes, and then eventually reach the client. That's ridiculous. And it's funny, a lot of people might say, oh, but the technology will get better. Well, here's the problem. It's not that whether or not the technology will get better, it's a problem of the way it's inherently designed. If you're saying you have to, and this is simple physics here, if you're saying that in order for me to send a message, things have to traverse more space and time, guess what? There's no amount of design you're going to have there. It's still going to be astronomically slower than something that needs to traverse a very, very quick, very straightforward amount of space and time. If I'm sending directly to a centralized server, it's only going one place. It's going to that service, period. If I'm doing it through, let's say, a blockchain, well, guess what? It's got to go into a block, it's got to be mined, all that consensus has to happen, and then it has to propagate to nodes to where enough people have it, and now it's updated, and now the rest of the network is aware of it. Yeah, there's no time for that. Our economy, our global economy is working in nanoseconds and less. You know, we ended up being that fiber optic cables are not fast enough to send, using light, obviously, to send information, nor are satellites. So what do a lot of these trading firms use? They use radio waves. They use that to send trading information or, conduct some trades. Companies will typically buy buildings next to the New York Stock Exchange just so they can get trades into the exchange faster, because they just have to traverse a whole lot less of space and time. Now, with that being said, imagine if that system had to go through a consensus algorithm, had to go through a whole mining process, and then had to propagate to nodes. We're talking about literally crashing the global economy. It doesn't make any sense whatsoever to ever adopt a decentralized topology as the core functions of the web. There are aspects, though, that make total sense to adopt decentralized technologies and incorporate it into the web. There's also some technologies where a decentralized network should be, and the only viable design is inherently decentralized, and that example would be cryptocurrency. Bitcoin was widely successful because it was new technology. It wasn't using stuff like HTTP, it was using a little bit lower level stuff, a network layer protocol obviously called TCP, but it took a lot of these things into account. It was more about efficiency and transparency than it was, for replacing, something that can be sent to a service immediately and be processed. It's cheaper and easier to send $10 over PayPal to another PayPal guy, which it's a whopping $0 to do, to send someone $10 on PayPal compared to on Bitcoin. There's a transaction fee, but there's some benefits, obviously. When it goes through clearinghouses and you're dealing with banks, there's situations where, a PayPal to PayPal isn't exactly the situation, and that's where Bitcoin comes in. Obviously, it takes government out of money, which for a lot of people, and especially for me, I think that's a very big deal. Yeah, the point is that you have all these decentralized web-based projects, and then you have us. We're saying, look, the web is only viable in this specific topology, but it can use decentralized technologies to further enhance it. Something that Jack put out, Jack from Twitter, Jack Dorsey, he said that cryptocurrency, in a nutshell, is that cryptocurrency was going to give rise to a new web. And he's totally right with that, in the sense that a new web should first of all be the same setup that we have now in terms of the topology, with the addition to obviously making use of decentralized tech, but again wired into cryptocurrency. So Fiat, for example, is married to in some way, shape, or form, but not dependent on the universal web. So it makes use of a lot of things that happen in the universal web, and it actually enhances the function of it, specifically in relation to its proof of work and UDSP packets for congestion control. And there's another aspect to the universal web that helps Viat, which is like the identity certificates and the UDSP, that entire encryption process, the DIS, all that stuff helps Viat. But with that being said, a lot of our competition is not focused on actually revolutionizing these core technologies. They're focused on, hey, how can I extort a massive amount of money from my audience without them knowing? And obviously, Waves has their own thing. They're handling it a very specific way. Obviously, we disagree with that. And we can point to a ton of reasons why it's not viable and not realistic. If you think the brilliant people at CERN who initially developed the World Wide Web were anything but brilliant, or couldn't think about a different type of topology, I think you're dead wrong. And I think you might be a bit arrogant, because the truth is they were brilliant and they knew exactly what they were doing, and they designed it appropriately. Now, there are issues that people bring up, like privacy and all this stuff. It's funny, something like IPFS then would be something that they'd be, in line with. But the problem is that things like illegal activity and, unethical stuff related to illegal pornography or criminal organizations thrive on those types of networks. And then they go, okay, they do a public response, which is, we'll make a whitelist or we'll make a blacklist. So then, wait a second. You said your entire purpose of creating your supposed decentralized web was to make sure that everyone, has the ability to be open and not be censored. Well, now you just created a way to censor people, at will, at mass. So it's just absurd at that point. There's legitimate reasons to use that type of network, but it's for specific situations and for a select number of people. Like if you're in a tyrannical country. But ours would work in something like that because we have decentralized aspects to decentralized bits. So our DIS obviously has a decentralized component to it, right? There's a mirror version of each. So the DIS has a centralized version, but it also has a decentralized version. So you can be in China, for example, use the decentralized version to bypass some sort of firewall and still walk away happy. If it's a a static asset that you want to have access to, you can still use the decentralized bits if the site is static in some way, shape, or form, or if it has some dynamic bits and it distributes that accordingly. Basically it allows it to be distributed to the distributed network so that anyone who opts into just using the decentralized ones still have access to it. But yeah, there's a balance between everything, and that's the most important part. But I like the quote that kind of Einstein has, and I'm going to try to do it appropriately, but essentially what he said was when they were attempting to describe what a quantum particle looked like, some guys said, hey, it might be wave-like, some guys said, hey, it might be particle-like, and Einstein came in and said, and I'm sure among other people, hey, look, guys, it might actually be that it's both sides of the coin. And lo and behold, what did we have? We had wave-particle duality, where a quantum particle has both wave and particle-like properties. So there's no reason to limit ourselves to one side of the coin. And if you do that, you're going to lose all the benefits to the other side. You can actually have a hybrid topology that takes all the benefits, and as so long as you take you take everything into account, you do your due diligence, then you can create a network that's harmonious, that's well balanced, and that doesn't have the disadvantages of either network type, and is actually cheaper and easier to maintain. Now, obviously, that's only true in the a software-based network. If you apply this to a hardware-based network, it gets a lot more complicated. You're going to have a lot of the disadvantages of both and all that stuff. But again, we don't do that. Most of the new companies, tech companies, aren't doing that. They're doing software-defined networks. That's kind of like that's very old. No one does that stuff anymore. But yeah, the point is we're addressing real problems and we're providing viable solutions. A lot of these decentralized web projects think that the web's issue is only related to its topology, and that's how I know they're totally full of it, because if they actually understood the problems that the web faces today, it's inherently about the outdated core technologies that we rely on. That is a far bigger issue than having a centralized topology. Far bigger issue. We're talking about the web slowly killing itself. This is where net neutrality comes in, this whole bandwidth crisis. This is something that runs up people's bandwidth bills. It's going to be a reality more and more when people realize that all these devices come online means that no one's going to have unlimited anymore. There's going to be a form of congestion control that is going to hurt your pocket, and the form of congestion control that's going to hurt your pocket is called a bandwidth bill. You're going to have to pay for per GB or per MB. In some places it's per MB if you're like in Africa, for example. But yeah, that's a reality. Those are the actual issues with the web. A lot of these decentralized web projects they tout saying privacy or these really silly arguments that make no sense, that are not even they don't even affect 99% of the people on the web. They affect maybe criminals or people who want to, people who are censored. But there are a very select amount of people, and some people who are being politically censored, that's a problem. I totally agree that that's a problem, but you don't solve that problem by making something like the bandwidth crisis 30 times worse by adopting a decentralized topology. A decentralized topology would raise the costs, it would add more to your bandwidth bill, and it would cost a crap ton more money for both businesses and consumers. Especially if you're a client using the network as compared to a service, those bills that the service would typically have are offset to clients. But another thing that I think is really telling is when these decentralized web projects, or these decentralized projects in general, like Bitcoin, get so big that you realize that, let's say the blockchain grows 200 years from now, it's going to get really big. It's going to get massive. With that being said, and most people aren't going to have it, a full node and whatnot doing all this work. We're going to have stuff like a Lightning network, like we obviously we have for BTC now, which has tons of benefits, but that's far more centralized topology than not. With that being said, as these networks get bigger and there's more and more users, naturally, organically, it will form a hierarchy. We have that in nature. We're going to have it in our networks. This universe has a lot of fractals, and in this way it's going to happen. It's just a reality that a lot of these decentralized networks, as they grow and they expand and more users get on, more demands are put on the network. Naturally speaking, a lot of people are not going to be doing full nodes. They're going to depend on other people doing full nodes, and then those are going to shrink more and more and more because it's going to cost more money to even do those operations. But yeah, I mean, just from a viability standpoint, it doesn't even make sense. The argument's pretty bad. But when it comes to our competition, I would throw stuff like anything that's attempting specifically to replace the web as our, kind of our competition, but in reality, when it gets down to it, a company like NTT or a network service provider like IBM would obviously look at something like that and kind of laugh about it. If it was to replace the web we have today, they might obviously support some type of blockchain-based technology or some sort of decentralized tech because there are use cases for it. It is viable in certain contexts without a doubt. But in terms of replacing the web with it, no, it'd be catastrophic. It would destroy our global economy. It would make a lot of people homeless, a lot of people poor, and strip a lot of healthcare away from countless amounts of people. But yeah, with that being said, we kind of shove pretty much every single project in this space that wants to replace the web as kind of our competition. But when it gets down to it, it's not competition because we have a totally different philosophy, a totally different outlook, and we're solving a very different problem. We're solving the actual problem. Another thing that I like to point out is that when this industry uses the word protocol, they use it very loosely. When we use the protocol, we're being very specific. We're creating a data transport protocol. A lot of these other quote unquote fat protocols, like Bitcoin's an application layer protocol. Underneath that is a data transport layer protocol, and underneath that is a network layer protocol. Examples of a network layer protocol is like UDP and TCP. A data transport protocol is like HTTP, UDSP, QUIC, things like that. Above that, these application layer protocols are where the rest of these decentralized web-based quote unquote protocols exist. Not really protocols, they're based on HTTP large in part, and they have some type of UDP discovery protocol that they also use in conjunction with it. They're not really building any type of new protocol. You can, in terms of the English definition, use that, and you can say it's an application layer protocol. But I think it's a grave injustice to say that. I think it'd be more appropriate to say there's an API, and that API uses a data transport protocol called HTTP. But I could see, for the sake of sanity, and I guess the sake of the network, and more specifically for marketing purposes, them using that. But yeah, a lot of these decentralized web projects like to tout that they're making a new protocol, but in reality, they're not making anything but a bloated, worthless, non-viable API that would make absolutely zero sense for any company, the global economy, the stock exchange, or anyone who is doing time constrained operations to use. It's absolutely absurd. One thing that I think a lot of people don't realize is that development, especially in terms of a network, should never stop. It should always be ongoing because, just like HTTP in its situation, the moment you lock yourself into a design or an architecture or certain semantics, you're going to screw yourself long term. So the way we have it is that we want to obviously work with the community. We want to be able to see what people's needs are as they arise and kind of get a gauge for what future demands may pop up, and make sure that the protocol is dynamic enough or flexible enough to function in pretty much any environment in any situation. But with that being said, we're actually quite a substantial amount of time ahead of schedule. We're definitely over 3 months ahead of schedule, and that seems to be increasing as we become more and more proficient. At doing this stuff. A lot of the big hurdles, like for example, the reliability protocol with UDSP and certain security aspects to it to keep a stream open or close it, things like that, will take much longer, and chances are I wouldn't ever say that it's 100% complete. I wouldn't even say it's 90% complete. I would always just say it's probably 50% complete, because chances are something's going to pop up, something's going to change, demands are going to adjust, and then you're going to have to reevaluate things. And that's something I don't want to fall into, because that's why the web today needs WebRTC, WebSockets, and then on top of HTTP. It just gets ridiculous. You're not taking into account the variety of needs a protocol could be used for, or what the web or an application may require. But with that being said, I don't think we'll ever give out an exact date for the Viat swap until it's very close. It's the same view we have with exchanges. The last thing we want to do is kind of be like, hey, here are some things we're saying that could potentially adjust or modify or raise or lower prices for the, for whatever is out there. What we're afraid of is that long term, we expect new regulations to come out to where if you're kind of like if you have a stock out, if you're doing something or saying something with a direct intent or can be a perceived direct intent of modifying prices, and it's quite a ways away where that date may change. It could be a Saturday and then ends up being a Sunday, right? Even like that, even that from that perspective, we suspect that regulations and possible lawsuits will be handled by the SEC for that. This is a strange space because it's legally gray and it's a lot of bleeding edge technology and it's a weird mash of a lot of different types of people. With that being said, we really have to be careful. We're an American company. We play by American rules and we'll always, try to operate as legally as possible. It's funny, a lot of companies in this space will, blow through, let's say, 30 million in 6 to 12 months and then go under or, never make a product like Sub did. And there's many others. We've been here for a while. We've been doing software for a while. We've developed a bunch of different things. The web that you have today, we have our own little fingerprint in there. We have our own little ripple in relation to a function we wrote, although it was scooped up by another guy and it at least linked to one of our products, which was for JavaScript benchmarking. That function was called FastApply. If you go on GitHub and you search jsperf.linkage.com, you'll find tons of projects that reference products that we made that are in source code commented out. And this specific function called FastApply just happens to be a huge dependency for tons of projects for the web today, and especially a few years back. So I think it's safe to say if we weren't here, we weren't providing stuff, it just wouldn't be the same. It would 100% would not be the same. But how different it would be, obviously, anyone's guess is as valid as someone else's at that point, because it just, this is the only reality we know. So to guess otherwise would just be foolish. But one thing is for sure, it would be different with us, not being here. But I'll digress. So yeah, I mean, we'll never announce. I won't even say we announce a month ahead of time. I think we would announce maybe like 6 to 7 days ahead of time, kind of like how we do now with exchanges. We get down to like maybe 3 days, and then we give everyone kind of a heads up that this is going to happen because it's very close. We make sure everything is perfectly set in stone, so there's no room for change there. Otherwise, I think it's a legally gray area to kind of operate in that respect. You're kind of teetering on the edge, especially if you're an American company. But in terms of the network, I expect to be fully operational by January, I think for sure, for Sentivate's universal web. I think it'll be sooner than that personally, but development obviously changes, things come up. The community might want different things. They might ask for certain features. It'll always change the development roadmap if we have to get in a certain browser feature or function because the community wants it, or it'll make things easier. In terms of Viat, that'll either directly follow suit or get kind of jumped on, I'd say, near the end of UW development, where it makes sense to do that. Mainly because Viat depends on a lot of the core technologies that the universal web, that Sentivate's web portion actually has. For example, UDSP, the DIS service, a lot of these things Viat takes advantage of. So if you were to develop Viat first, it would be like doing it backwards. It wouldn't make sense. But yeah, Viat, we want to give a lot of people time for it. Obviously, one of the biggest things is, and to avoid having something like a bunch of forks, which is mainly from people having a bunch of different opinions. So they'll just be like, oh, I'm going to fork this crypto, and it's only a small change, a small difference. we want to kind of have it so that there's no need to fork it. There's no reason to, because we basically have found this perfect balance. That's the whole idea of allowing the community to kind of vote on different features and have their own say in the project. But it also ends up extending it, because you can't really suspect or expect if the community is going to have an issue with a certain feature. It's going to be something that's going to pop up late or pop up after the fact, and adjustments will have to be made. But yeah, like one thing I never want to do or be in a position doing is offering any type of guarantees, offering any type of promises. I think any project or any company doing that should seriously consider their legality. And if they're operating morally or ethically, because in my opinion, the moment you do that, you're not, because you're basically saying that you expect the future to only be one certain way, with 100% certainty, which is absurd. No one could know the future. It's not going to happen. You can make assumptions, but there's no way to tell for sure. An asteroid could hit us and it could change everything, right? But with that being said, yeah, we try to avoid doing anything like that unless it's very near the date and it's not going to interfere with the market too much. And there's very little time for people to react. It's just, okay, it's coming up in 2 days, coming up in 3 days, it's coming up in a week. That's I think as far as we'll go, like about a week. Like we made everyone aware that this browser demo was coming out only about 7 days ahead of schedule. In everyone else's mind, they had no idea that we were already at a point where we're integrating UDSP into browsers. It was just what was on GitHub, which is basically a UDSP server and client module, along with certificate signing and cryptography and all that stuff. I think in terms of that respect, I think we're going to surprise a lot of people. I think we're going to move faster than a lot of people suspect, but there's always going to be room for variability or taking into account community opinions or community-based thought or community voting, and that might change or alter development. SNTVT, the ERC20 token, will not be that the idea of an ERC20 token or the Ethereum network ever playing into Veon is obviously wrong. We have no intention to stick with an ERC20. We have no intention of using Ethereum, any more than we need to. It has its use cases. It's great for onboarding. It's a great way to incentivize a bunch of people to use our technology. Honestly, I think this is the only space that would make developing a new web actually possible. There's not a single space in technology right now today that would even make this a project like this where we're really pushing the limits on everything. It's extremely technical, it's extremely deep, but at the same time, it requires adoption. From a company standpoint, there's specific applications or specific situations that make total sense for it. But if you really want to obviously have that, the masses and have a bunch of adoption for it, an ERC20 is a perfect solution. And this industry without it, it would not be viable. It would not make sense. It would not be an option to even attempt to do this. It would not be realistic. It wouldn't be viable because there's no way to really go about it. This is really the only space that makes this sort of project possible. Viability is its own cryptocurrency. It's on its own network. It's on what we like to say is the Sentivate network, but obviously in reality, there's two different networks going on. We're building two separate networks, two different systems with two opposite topologies, but they share a lot of the technology and they actually enhance each other, right? So they provide functions to each other that are interoperable but not dependent. But yeah, it's its own cryptocurrency, its own mainnet, its own everything. Everything we're building for it is from scratch. It's not a fork of anything else. The blockchain is set up where it's more like a DAG. It's more like it's just transactions linked to other transactions that are being validated, and it kind of spreads out in any other way. If you were to look at it visually on a map, it's not one after another type of block. A lot of different blocks can be mined at the same time. And the idea there obviously is to have a highly performant network. I think if you look through any of our stuff, one of the most consistent themes is efficiency, reliability, and being realistic about everything. You want to make sure that you create viable technology where a lot of people can use it, and it's efficacious in its design. It takes into account future needs or future demands, but it still remains flexible. if things need to be adjusted. Oh no, definitely not. So there are some great use cases from an economic perspective from having something like staking or a proof of stake, for example. We have that sort of mechanic where when you're, let's say verifying transactions, aka mining, um, uh, basically depending on the amount you have in your wallet, the algorithm kind of adjusts to that. So anyone who has more in their wallet, as long as they're doing the same type of work and the same amount of work, obviously they'd have the person with more sitting in their wallet would potentially get more out of it. The idea there is to incentivize folks to hold on to it, to not move it, and to kind of contribute more to the network and from a community aspect. Um, I got a lot of that feedback initially with some folks who had issues with just straight proof of work. But the reality is that a straight proof of work, um, like we have, is actually kind of similar to the proof of work style that is actually in proof of stakes, proof of stake mining and master nodes. It's really just mining transactions, in an acyclic graph. And if you have a little bit more in your wallet, you could potentially get some more out of it. But other than that, no, we don't use master nodes. We don't use any tech related to that. Everything obviously is from scratch. As to why I encourage a lot of people to get on the GitHub and kind of look at our style, even from a code style perspective and code linting. I think you'll see a huge difference between our code and another project's code. Any project in this space that's doing node-based work, I'd reckon that we'd probably already be, from a linting perspective and from a code style perspective, drastically better. As we have a very long list of rules for ESLint that keeps everything, in tip-top shape. But yeah, it's not a staking model. It's not anything related to a master node. Any type of tech that you're used to now, it's going to most likely be a Frankenstein, I guess is a good way to put it, a mix mash of a lot of these different perspectives in kind of our model. The economic view that I have is mostly something from like Milton Friedman or Ayn Rand. Obviously capitalistic, an idea where everyone has equal opportunity, but we don't focus on equal outcome at all. There's this saying by Milton Friedman where a system that focuses on equality first and not freedom ends up with a vast amount of inequality and a limited set of freedoms. But a economy or a sort of system that focuses on freedom first actually gets a high degree of both, comparatively. But yeah, that's kind of our take on that and how that kind of ties in to, proof of stake and all that stuff. There's a little tie-in in terms of the way our algorithm is set up as of late, but again, the community is kind of a driving force behind any changes for that or alterations. The more people we talk to, the algorithm may grow, but chances are it's pretty good right now, and I think a lot of people would agree with the setup that we have. The recent adjustment was to add a small proof of stake like feature to it, but ultimately it's more in line with a typical proof of work. It is technically though a dynamic proof of work because there is a optional second proof of work that you could do, depending on if it's on or not on the network. Basically, governments, private sector institutions could pay the network, obviously in Viot, to do some type of computational intensive or distributed supercomputing tasks for the second proof of work, and that's totally dynamic. So an example would be, from a mathematics perspective, maybe calculating large primes. From a biology perspective, maybe like the folding of proteins, or from a astronomy perspective, looking for new stars or looking for planets in the Goldilocks zone, right? This all requires massive amounts of computational ability and in a distributed fashion to obviously meet time constraints. Because the last thing you want to do is have to compute a problem, have the resources, but it'll just take a long time to compute it. In this case, because it's distributed, there's a lot of different computers, a lot of different machines doing little bits of work. So it's really fast, it's really efficient. It has a use case in the network in and of itself, being a form of congestion control for the universal web and a proof of work for Viot. In this case, obviously an additional proof of work. So we call it a dynamic proof of work, and there's some proof of stake perspectives to it, like aspects to it. But mainly the standard setup you'll have is the small proof of stake aspect with your typical proof of work. When the second bit is turned on, or if it's turned on by default, which we might do, and it would totally adjust, obviously, the rewards that you'd get from Viot. But obviously, the other side of it is that you're going to have to spend a little bit more computational ability, a little bit more resources, CPU-wise, to solve this specific problem. It'd be cool, and we would hope to at least experiment with it, having an additional dynamic proof of work that might specifically be for certain types of machines. For example, or hardware. It might be something that's GPU specific. So only those with a GPU could do this other dynamic proof of work. It would be not designed to run on a CPU, and it would be computationally intensive for a CPU, and to the point of it being nonsensical. It's better just to run it on a GPU. The way Viot ties into UDSP is via a packet puzzle. So there's this really interesting academic paper put out called Minimalt. I think it's actually one of the main papers where Google got a lot of its ideas quick from, and I think probably HTTP3 has a lot to thank in regards to the research done, the stats put out by the Minimalt papers. Sadly, it didn't go anywhere. They lacked basically vision and actual implementation, but they did a lot of R&D that highlighted a lot of interesting problems that are right now unresolved and won't be resolved even with stuff like HTTP3. They're more related to like the DNS side of things, but one thing they pointed out was basically forms of congestion control and DDoS protection and connection liveliness. So Viot puzzles are put into, or at least linked to, inside a UDSP packet. So let's say if you're connecting to newegg.store on the universal web, it might have packet puzzles turned on to basically buy the server some time to alleviate resources, right? Because it's a form of congestion control, and if you have a lot of people connecting to the server, obviously you want to introduce some type of time to slow down connections so that resources get sucked up a lot slower. So the way to do that is by providing a dynamic puzzle, in this case a proof of work, that's basically a Viot proof of work inside the packet as the first response. So you send your request to this newegg.store. It responds with this puzzle in this UDSP packet, and your computer spends some time to solve this, but it provides enough time for the server to potentially free up some resources because someone ends up disconnecting or leaves or whatever, and then that RAM or that memory and that bandwidth frees up, and it's easier to manage. There's various forms of congestion control, and it's handled on a lot of different levels. The Cloudflare, loading screen, Google CAPTCHA, solving the images, stuff like that. There's a lot of different varieties of congestion control, but on a packet level, on a protocol level, the implementations are pretty lackluster or non-existent. So one of the things that you get on the universal web for these UDSP packet is this little puzzle that's a Viot proof of work. You solve that proof of work, and your ephemeral key pair that was used to conduct that work and obviously do some cryptography to sign off on it, gets a bit of Viot along with the service. So Newegg could get a little bit of it, and you can get a little bit of it. But that sharing can actually be dynamically adjusted. So Newegg could say, actually, we want to give all the profits to our users for the transaction fees, and we won't take any. They could also potentially do 100. We want to leave that there and like that, because it also is an effective way to boycott services by using, your economic or purchasing power. You're kind of like using your bandwidth and your computational resource to boycott a service now. So if Newegg decides to take 100% of, let's say, the Viat profits for that puzzle, you can, all collectively can boycott the site. And if it relied heavily on that for, finances or a source of revenue, uh, now they got hit. And now they have to adjust their moral or ethical standards to meet, this new market pressure. So with that being said, that same ephemeral key pair that you have to establish an encrypted UDSP connection, and keep in mind this is a bidirectional real-time connection. So imagine like if HTTP and WebSockets kind of were mashed into like one in terms of the features. It's basically that's a UDSP connection. So that the same ephemeral key pair that you use that we also call identity certificates, or from a browser's point of view, we just call them profiles to keep it really low level and really simple for the average Joe. It just looks like a profile. You generate a new profile and it comes with a master certificate and an ephemeral certificate, and both are signed by an identity registrar. The ephemeral certificate is also signed by the master certificate. So with all of that, you actually get in those two certificates, you get a multi-signature wallet, Vion wallet. So if your master certificate gets hijacked, your ephemeral certificate is still safe, let's say, no one actually has access to your wallet. Now, let's say they guess the ephemeral key pair, totally fine. You still have the master key pair, they can't get into your wallet. They get both, it's the same situation, but the likelihood of generating both in terms of brute force is much more difficult. It might be nearly impossible in terms of today's computational ability and today's computers. Obviously, it's different if you have Shor's algorithm on a quantum computer, and it obviously has to have a quantum computer that can implement software that like we have today, as compared to what they have now, which is it's not the same. It's implemented a very different way, and it's more mathematical. But with that being said, if they were able to do something like the Bitcoin Hadron Collider and brute force one of your keys somehow and got one of your keys, they wouldn't be able to tell if they could get into that wallet because they don't have the other key. So and they wouldn't, even if they could tell that this key was for a specific wallet, which we may opt for that, which is more transparent and makes a little bit more sense. But with that being said, even if they could brute force that one wallet by just straight up guessing a bunch of wallets, like the Bitcoin Hadron Collider does and a bunch of other projects do, they would still be effectively at square one because they wouldn't have the other key pair. So the one problem that a lot of cryptos have is that it's a single key that can be guessed at random potentially, and some actually have, and people have lost money from that. But if you take a multi-sig wallet approach, then the chances of getting brute force decrease drastically. So ours are multi-sig by default. But with that being said, this ephemeral key pair that you're using on the universal web and UDSP packets to establish that bidirectional encrypted connection is also first of all, a single sign-on for the entire universal web. It's also a passwordless, usernameless login. It also can do instant signups and instant logins. So all of this happens, all of that stuff right there happens in a zero RTT connection. So the moment you send that packet sets up an encrypted connection, a bidirectional stream, which is a real-time stream in layman's terms. And you also can sign in / immediately sign up to the service. So you never have to rely on, you're basically relying on cryptographic primitives, strong cryptographic primitives, math, essentially, than, your traditional password or username, where it's all, human generated. Sometimes people have password generators for the browser. But the problem is that it's much better to have this approach as compared to even generating a small string automatically for like Chrome. First of all, it's a much bigger string, and it's also using a cryptographic process. And it all happens in a single packet. So you don't have to constantly transmit all these packets, aka all this data, Again, helping solve the bandwidth problem. A lot of the technologies that we have and that we're working with are designed to solve this problem on top of a bunch of other issues. A lot of, I think something you always see with us is that a little piece of technology doubles as a lot more than just one thing. For example, the ephemeral key pairs for the universal web, aka your profiles, are also Viot wallets. So you end up using Viot and these UDSP packets. You end up doing some proof of work, some mining there for a packet puzzle. So you can gain access to, say, a service for congestion control purposes, or it can also be for connection liveliness checking. So while you're, connected to this service and it's a real-time stream, and the way you keep connections open is actually through what you call typically a ping pong. It's just not, there's no actual way to know that a connection is consistently open besides something like on a quantum network where you're using superposition to determine if another particle is still there and still in the same position, let's say. But in our networks, obviously, it's nothing like that. So the way you tell if a connection is continually live and open and still active is through a ping pong. Basically, you send a ping, it sends a pong, right? So you send basically ones and zeros back and forth. And this happens every 15 seconds, 30 seconds, depending on what type of network you're dealing with. Typically, connections on routers will be closed, and then on the comps will be closed in like 15 to 30 seconds. So usually in that time period, you'll always see like some type of ping pong activity, keep it open. So that's what you call connection liveliness checking. Basically, you're just seeing if the other side is still there. For the client side, you would just send a 0, let's say, but the server would send, if it was checking, a proof of work, so a Viot proof of work. So something you would usually do anyway. So this isn't passive mining. Let's keep in mind, this is not passive mining. This is not like sub. We would never have it mine in the background, suck up all this CPU power and battery and all this stuff just to help mine some cryptocurrency. There are full nodes that you can operate, and if you want to actually mine, it's much better off doing that. It's not economical or rational from just a resource perspective to just mine Viot through your web activity. It's more of just, hey, it's supplemental, and it also just happens to be extremely useful to do a proof of work for connection liveliness check-in or DDoS protection, things of that nature, congestion control, than pretty much anything else. It's very low level. It's very efficient. Computers can do this. It can be, it's kind of like machine to machine type of stuff. It doesn't involve a human being in the mix here. This all happens behind scenes without you knowing it, and you can generate Viot in the process. And again, it's not always on. It's not being done in a passive manner. It's being done only when needed and only when requested. But that's basically how it ties in to the universal web. And that's why the universal web has a high priority over Viot, because a lot of the things that we're building in the universal web just so happen to also double as some type of Viot functionality or feature or aspect. So adoption has a few different ways, a few different angles. From a business perspective, getting companies on board, there's things ranging from guys overseas in select areas or militaries that need access to the web, but it needs to be fast, it needs to be efficient, and or in a situation where bandwidth really counts. You're paying per megabyte, it's a big deal, it's time constrained. We want to provide solutions to companies or governments that may need that type of technology or need aspects of that technology for setting up, let's say, a network someplace else, or access to a network across the globe, but in as efficient as possible manner. Another aspect is, say, desktop applications that are web-based and that rely on, quick and fast networking or a lot of requests. Examples could be, Amazon, Netflix, they're on Apple TV, for example, or Roku. A lot of these applications, you don't need users to know how to use a Sentivate browser for all this, or any browser at that range. They're just applications, so a lot of the internals can be modified appropriately. They can, for example, adopt UDSP or a DIS type of service and be 20 times more efficient than they're the HTTP DNS alternative. Another one is, for example, Binance, or trading applications. So the Binance app, the one that you download on desktop or on mobile, could use UDSP, and they would be able to process far more requests, do a lot more with a whole lot less. They'd save themselves a lot of money in time in the process, and obviously a lot of headache for any users who are or traders who are using, say, the Binance API, or they're just using it on the phone and they want to make trades happen as fast and as efficiently as possible. You'd be able to do far more trades with UDSP than you would with HTTP. Yeah, so there's that aspect to it, to providing, let's say, business onboarding to get them to use our technology or use aspects of the network. The other perspective is how to get average day people on. So average Joes, we actually are providing a ton of apps that we took off the market, like Hermes, where it's like social media automation. It's AI-based social media automation, and it also looks almost completely human to social networks. So there was this whole thing where they were Facebook, Instagram, so on and so forth, were banning apps that were doing like mass liking, mass commenting, basically different marketing efforts. Anything that was automatic, they banned, and then they rate limited on their developer API. So $1 million companies that were built around these features just went belly up overnight because Facebook sent them a cease and desist. So they couldn't actually provide these features and packages to users anymore, and they had to exit. However, we operated in this space without ever having to agree to a developer API because our applications directly interfaced with the browser. So it went through a browser. It looks like a browser. It had, it's an AI at the end of the day, and it kind of acted how a human would act. It would scroll, it would click, it would move around. It would seem as if it were completely human. So you couldn't actually find any type of patterns in here. A lot of the actions were based on, let's say a simple random number generator between requests or between actions to add variety to it, add a bit of, unpredictability to it, essentially the human element, as compared to, an AI that's robotic, and it's just, there's a pattern because it's so fast and it's doing everything, in quick succession, as compared to a human, which might take time to browse stuff. So imagine just looking at a browser, and this thing is moving around the web page for you, interfacing with everything for you. That's effectively what Hermes was. And we were able to operate in that space without getting affected like all these other companies, because we didn't need to agree to developer API. We didn't even need to use it. The app directly interfaced with the front end of their app. So there was no rate limit, there was no developer API to go through, none of that stuff. Everything that you could do, normally yourself, you had the ability to do in Hermes. Yeah, so there's that, and there's apps like that we're releasing. We're also playing with the idea of an exchange, but there's a lot of licenses that you need here, obviously in the States, to make that viable. We speak with a lawyer at the time, and he says that, if Rob, for example, or Rob refers us to someone else, because it's a very specific legal question, if they recommend that we set up maybe in Singapore or some other country or Malta, right, to operate more legally, then we will. But we prefer, obviously, to operate by SEC rules, and keep within those boundaries. We're just an idea we're playing with. We don't know if we'll actually, include an exchange or follow through on it. If we do, obviously, there's a whole legal process we have to follow to make that happen. But yeah, besides that, we're doing stuff like social networks, offering features that you'd usually find on bigger networks like Facebook or Google Plus, where you have all this, real-time communication going on. And keep in mind, a lot of the real-time features that you're used to, even like messaging, for example, will be much faster on something like a universal web, because you're relying on core technologies that are far more efficient than, obviously, the alternatives like HTTP, and traditional web apps. Ours are single-page reactive applications that, as you're using them, they build themselves. So imagine like walking across a bridge, and it's building itself as you're using it. That's why it's so useful in even bandwidth-constrained environments, because from an application perspective, the way they're built, it's meant to be extremely efficient. You only get what you need when you need it. That's it. You could, if you wanted to, and you were a developer and you design your application to request assets ahead of time, you could do that, easily do that, but we advise against that for the most part, because if you spread out the requests, then it's pretty efficient for the most part. Only in bandwidth with constrained environments would you think about maybe requesting assets ahead of time, or in that sense, you might actually try to spread requests out as much as possible and use as little as possible, because it's a bandwidth constrained environment. You don't want to obviously suck up a bunch of bandwidth at first. But that's up to how the app developers, hybrid app developers, actually want to treat things. In that sense, where it's bandwidth constrained, it might actually be better to avoid any type of decentralized aspects, because it would obviously, you needed like a discovery protocol going on, or you need to make a lot of requests to other networks or other peers, and that will obviously suck up a lot more bandwidth than just getting your assets from a single place. So again, it's all like, it's contextual. But yeah, then there's a bunch of different aspects, even for example, government, where we wanted to propose this as a replacement for, or at least a use case for private government intranets, where they're at these actual locations, they're physical locations, they're not accessible out of the network. You have to go there to actually use them. We would like that to be adopted in that respect, and maybe get some type of government influence in that regard, as that's what we initially were building the network for, to set up as kind of like remote installations that were at physical locations. And from a security standpoint, it's much better to have technology that your adversaries don't know how to use or don't know how to exploit, than obviously technology that is already very well known, very exploitable, and has a lot of issues that are inherently not very solvable because of basically design constraints. HTTP is just designed a certain way. Its architecture is designed a certain way. It has semantics. To go around changing that would basically break every single application that it plugs into. But yeah, there's a whole laundry list of an onboarding process that we're going through. And I'm most excited about building a lot of the apps on it to get users on board. Like Hermes is going to be probably one of the first ones. It'll be a different name, and be rebranded, and have a lot more features, obviously, because it's using stuff like UDSP. So its feature abilities and its feature base are massive compared to what we could have done before. The social network is, again, another thing that I'm really hyped for, especially in terms of building. We can get a lot of really interesting and cool real-time features that are not like economically viable on the traditional web, but are very easy to maintain and kind of update and provide than otherwise. Another way Fiat ties into the universal web is through buying products, let's say on a site that accepts Fiat, or for example, tipping. So you could go to a website and on the universal web, and the key pair that you get from the DIS is the Fiat wallet for that site, if they so choose to use it. So what you can do is, if it's like newegg.store, you can immediately make a purchase, like just one click of a button with your Fiat wallet. Obviously, if you want some precautions in place, like verify that you want this to happen or put in a password, of course we're going to have those security related features. So no one could just initiate like you automatically bought this type of action, but you can obviously go to a store on the universal web and immediately make a purchase without really having to put in credit card details or any of that stuff. It's just boom, instantaneous, and that's really great for a few different reasons. So it's basically like a cryptographic credit card. You're not putting in any of your credit card details. You don't need to. If it gets stolen, in terms of like the address, right, which is the only thing the server is really seeing, doesn't matter. It's irrelevant. You're only relying on strong cryptography now to make a transaction. You're not relying on just someone having to know, a small set of digits. and possibly three numbers or four numbers of security code on back, and typing in your name and all this stuff. You can save what we're considering like a sort of buy certificate or shop certificate. It's a shop profile. Basically, you can add details to your existing profile in the Sentivate browser, and put stuff like your shipping address or your bill to address, and that's it. And you can have that cryptographically signed, so that if you want to go to a store and you want to purchase something like newegg.store, boom, you can automatically send that, and a purchase can automatically be made, and it'll automatically have your details, and it's cryptographically verifiable if you wanted to send the additional hash with it. But obviously, you wouldn't need to, as the connections are ready encrypted and set up with obviously the 0RT UDSP connection. So because that connection already went through a cryptographic process to become encrypted, and because you're using those keys obviously to encrypt the message which has your shipping details to them, obviously the sign in that regard, where it's signed like a certificate, is not really required. Outbound, or maybe through email, you could send that and it would, still be verifiable. But yeah, so there's a few other ways that Viot ties into the universal web, and that's an additional one compared to packet puzzles. So we are looking for new team members, but we have some standards. So if you're like Underwriter, and I guess that's a good example for, if you're like him, we probably won't use you, or we probably won't do something with you. There's a few different issues with him. He made the bottle browser for Bitcoin, and he did Planetara. So on this Planetara thing, the main issue is he talks about state machines. First of all, state machines are very easy to understand. They're entry-level stuff for web devs, for computer science in general. If you go to a boot camp for web dev, you're going to walk out in a week knowing exactly what a state machine is. And you might not even know what it is, but you're going to learn stuff like reactive libraries, reactive component libraries like React, Angular, Vue, so on and so forth, Reactive. Those are all state machines. Those reactive components are state machines. So with that being said, he writes a whole page on how overcomplicated he wants to make state machines seem, and esoteric, on top of getting actual details wrong. For example, when he was explaining infinite state machines, he said something that made no sense, mainly because it's either he's lying on purpose or he's being arrogant. I think he's lying on purpose, but at the same time, he's definitely arrogant based on his code base. He said that there was no resource limits because, in relation to the idea of infinite state machines, not realizing that infinite state machines, the word infinite is theoretical. Your network, the available resources to your network are your limitations. The available, computational ability or space required to compute or check a state on that network is obviously a limit. But yeah, with that being said, anyone who kind of does those things, if we look at their work and they're doing that, we won't even bother looking at them because it's clearly like you didn't do your due diligence there. The other thing, he did the bottle Bitcoin browser, saying that Bitcoin was a first-class protocol and that he was out, getting rid of HTTP. The problem there is he wasn't actually using the Bitcoin protocol, because the Bitcoin protocol, first of all, is based on TCP, and you should be connecting to a blockchain and making requests there. What really happens is he makes up this BS URI scheme and makes it overcomplicated and look esoteric, when it's just a very simple scheme where he plucks the hash from the bar and then throws it into an API request that uses HTTP to first of all, a service that's just an API for Bitcoin that actually interfaces with the Bitcoin blockchain. So he doesn't even actually directly interface with the Bitcoin blockchain, and he uses HTTP. On top of that, his code was written terribly. I submitted a pull request, and it's probably one of the closed pull requests now, rewriting and explaining how bad he is at writing code and how bad he is at actually using the language. There were hilarious fuck-ups like avail and template strings. It's just absurd to use the language like that. And it's more absurd to obviously lie to your user base, lie to people in general. So that's one thing that we look at is code style, code linting, proper use of the language. If you don't have that, or if you don't have those aspects, we won't even consider you, to be quite honest, because we want a team that's cohesive, that can work really quickly. We don't want a crazy large team for certain projects, or for certain situations. You want something that's just the right amount of people, that's cohesive. They have the same kind of mentality. They get along well together, and they're just as proficient as each other. So that's one aspect to it. But everyone is free to submit pull requests or changes or comments, alterations to our code base. We put up basically the base amount of our code base. Anything that's like being prototyped or is unstable, we won't include. Stuff like our reliability algorithm for UDSP, a lot of the other functions, we won't include because they're constantly being changed and altered, and the code is all over the place. It's got comments in it and everything. We're not going to ship that out. We're not going to put that on GitHub just yet. But what we have on GitHub is a great example of kind of the standards we have for coding in general, which are probably the highest standards for a Node.js project in this space. I haven't seen a project yet that kind of compares at all in terms of actual code use, so using the language, and then the code style, so how well it is organized, and the kind of the rules like that are in ESLint are used. But token ambassadors or Sentivate ambassadors, yeah, we're totally up for that stuff. Anyone can reach out to us and learn more. We'll definitely entertain that. Basically, if you want to know if you could potentially even jump on the dev team, just look at what Underwriter does and do the exact opposite. Don't lie. Big thing. Definitely don't lie, especially your user base. Do your due diligence. So don't say things you don't know about or don't comprehend. Don't say there's no resource limits because you miscomprehend what an infinite state machine means. There are resource limits. It's very obvious. If you can't wrap your head around basic physics there or just reality, then chances are, from a developer standpoint, you probably need a lot of work. And then the second thing is, if you look at his code base, it's terrible. It's misorganized. Uh, it's terrible use of the language. If you look at ours, you'll see that we write utility libraries. We write libraries that other developers would use to create applications. So from that perspective, we're used to writing very well structured, well written code. If you fit our style, and which is not hard, it's not a monumental task to simply up your um, coding abilities, but also like your code style and your linting, all that. Basically, your code quality. If you can up your code quality, then and match ours, then chances are you're probably going to be a good fit. But everyone's free to submit their own pull requests or their own comments, even if you're not a developer, um, to the repo, and we'll obviously adjust accordingly. Um, I don't know if we'll obviously accept the pull request, especially at this point in time. Um, but people are free to do it. If you're a Node developer and you think you could be a good fit, but you maybe just need to know a little bit more about linting standards, like using ESLint and whatnot, we can actually get you situated pretty quickly. So if you have all those other bits and you just need to up your code quality, that's not an issue. We can sit with you, work with you, and kind of show you how to write really well structured, high quality code. Um, the opposite of what we've seen in the big stuff like the bottle Bitcoin browser and Planet Terror or whatever. If you don't write code like that to begin with, then chances are you're going to be a really good fit. Two big aspects that we're involved in terms of charity is animal welfare, which is a big one for me personally. And another one that's very big for me personally is what we want to hold shortly, hopefully this month or the coming months, is relation to donations for U.S. veterans. Obviously, our co-founder Lunop is ex-SEAL Team 6. He's obviously a veteran. Um, and we want to be able to show our support to those willing to put their lives on the line for us. We all have, some of us, especially the co-founders, have family who are either police, in the military, or uncles, or some have passed, and we want to be able to show our support for those who are still here, or those who need it. And that's another big aspect that us as a company we like to get involved in, and like to show our support for our local community, show support for the people around us who need it. But yeah, animal welfare is a very big one for us, and we do stuff like sponsored fosters. We did one for Pookie. We held a vote for the community to vote on her name. She's great now. She's almost there. She's being socialized, but stuff that we'll do ourselves. Money can only go so far. Resources can only go so far. But stuff like, say, donating computer parts or laptops or a phone to a U.S. veteran, or someone who has the ability and the training to get their life together, or push themselves forward if they were given just a little bit of a helping hand. That's something that we're very interested in, and will certainly follow and chase. Um, you know, if you give a man a laptop, it's kind of like, you give a man you give a man a fish. He's gonna have fish for maybe dinner. But if you teach him how to fish, he's gonna have fish for a while. Um, Same thing with like a laptop. You give a man a laptop, and especially if you did not have one before, a computer at all before, it's a big deal. It's a big change, especially in modern society. So it's something obviously that ties into us, and it's a great way to kind of give back. Um, but yeah, I mean, animal welfare, I think you'll see a lot of. Um, we have family members who run uh, animal related shelters or charities of certain kinds. And we ourselves are involved in rescues, for example, for cats or for a dog, and we'll foster them and socialize them and get them up for adoption. Pookie was one of our recent cases. Before that was Sienna. Sienna was a sponsored foster. Pookie is a lot more work and a lot more effort, and costs a bit more because she was in very bad shape. If we did not step in or intervene at that time, she probably would have not been here with us today. But now she's doing great, and that feeling of obviously giving back is a big part of us as a company, and obviously us as people. We're solving these problems because we think they're very important to solve, just like going around and doing charity events, or giving back to the community in certain ways is important to us. It helps those around us. It helps everybody. It has a ripple effect, beyond just that single event. Um, but yeah, I mean, it's a big part of us as a company and obviously as people, and we look forward to hopefully getting involved more in those events, and and really doing more than just solving these very important problems in the crypto space. But we want to obviously have direct positive effects on individuals' lives.